the hidden influence of the gut on the brain. So we're going to start off talking about the gut-brain axis. The brain does not operate in isolation. It constantly responds to signals from the body. And one of the strongest sources of those signals is from the gut. So down the spine, right? The spinal column, the nerves, we have nerves that come from the brain and they go out to the rest of the body. And then we have nerves that come from the rest of the body back up to the brain. 80% of the nerves are coming back from the rest of the body to the brain, and mostly from the gut. The gut and the brain communicate through the vagus nerve, immune pathways, and microbial metabolites. We'll talk about what that is in a minute. But these signals influence brain function, stress response, and inflammatory tone. A large portion of the immune system is located in and around the gut. Okay, so we have the thymus, the liver, lymph nodes, the appendix. The appendix, by the way, is like a lymph node. Tonsils, the red bone marrow, spleen, the Peyer's patches. These are all inside the small intestine. There's a huge part of the immune system is right inside your gut. And the microbiome produces compounds that influences neurotransmitters, which is in your head, stress signaling, which is experienced in your head, right? Hormones, nervous system regulation, and more. And when the gut environment becomes disrupted, the immune and inflammatory signals can shift and travel throughout the body, including the brain. We're going to talk about how that happens. Because of this constant communication, brain-related symptoms can begin to develop even when digestion appears normal on the surface. So if you think that my gut health is fine, but you're experiencing all these issues in your brain, there's still stuff going on in your gut. It just hasn't gotten to the point where you've noticed it yet. So now we're going to talk about the gut microbiome. The microbiome is a collection of microorganisms, including bacteria, fungi, viruses, and their collective genes living in and around the body, like the gut, the skin, the brain, the heart, and the lungs. All of our organs has its own microbiome, including our skin, including our brain. They used to think the brain was sterile, and they realized that's not true. Our heart, our lungs, they all have their own microbiome, but the gut microbiome obviously is a huge concentration of these organisms. These microbes are crucial for functions like digestion, immune system development, and protection against pathogens, which are playing a vital role in overall health. And so today we are going to be focusing obviously on the gut. The microbiome in the gut sends chemical signals that regulate mitochondrial energy, detox, and inflammation, amongst other things. When it's balanced, you have efficient digestion, good nutrient absorption, strong immune function, calm mood, and clearer thinking. But when the microbiome is imbalanced, which is called dysbiosis, then it triggers a cascade of inflammation and the mitochondria reacts immediately. So just think of your lawn. If you have just all like beautiful green grass, right? Maybe a dandelion here or there, whatever, that's in balance. But if, like my garden last year, I say went rogue on me, right? That's imbalanced. You didn't care for it enough. Maybe you didn't feed it the right things. You let it go, and then you get dysbiosis. And dysbiosis occurs when this balance shifts, when protective species decrease, inflammatory species increase, or overall diversity is lost. So how dysbiosis changes the gut-brain signaling. So in a healthy microbiome, many bacteria help calm the immune activity and support the nervous system regulation by producing beneficial metabolites, such as short-chain fatty acids. A metabolite is something that the bacteria produce. So all bacteria excrete something. Good bacteria excrete good things, and bad bacteria excrete bad things. Short-chain fatty acids is a good thing and something we want to have an abundance of. But as dysbiosis develops, some microbes begin producing inflammatory byproducts that can irritate the gut lining and stimulate immune signaling. So instead of sending stabilizing signals, the gut begins sending signals of stress and inflammation. And then the brain is constantly responding to that input. So things that contribute to dysbiosis is repeated antibiotic use, highly processed and low fiber diets. And this is a big one, the fiber, because the microbes that produce the short chain fatty acids, which actually we're going to talk about later, feed off of fiber. So highly processed and low fiber diets, chronic stress, environmental toxins and chemicals, infections, poor sleep patterns, reduced estrogen. So as we age, that's why things seem to happen as we age, because our estrogen does reduce. And as a result, we can have dysbiosis. And then it's the dysbiosis that starts creating havoc. And also age-related loss of microbial diversity. All right, leaky gut. So a lot of you have probably heard of leaky gut. This right here is a little image of our little epithelial cells. Here is like a blood vessel. So this is the inside of your small intestine. So here's the little microvilli. And by the way, most people don't realize, we never learned this in high school, but you know how the microvilli are the little finger-like structures on epithelial cells, but there's the villi, and then there's the microvilli, right? So these would be the villi. Then on the villi are little microvilli. But on the microvilli, there are little other structures called calyx. That's just a little fun fact. But the gut it's not just one digestive tube. I mean, it is a tube. It starts in your mouth and comes out at the other end, but it functions as a highly selective barrier. So its job is to allow the nutrients in the body. So we want nutrients to get inside that bloodstream, but it's to keep out the harmful substances, keep the harmful substances inside the digestive tube so it can just be excreted out. And the gut lining is made of tightly connected cells held together by tight junctions. So these three little lines represent these like little junctions that are tightly knit together, and they act like gates, and they control what passes into circulation. That's why two people can be exposed to the same pathogen and respond completely different. So here is a representation of the epithelial cells, the little microvilli, but this right here is called the mucosa. So it's like a mucus forming. And so covering this is the protective mucosal layer. And what this does is help shields the gut wall from irritation, pathogens, and inflammation. And when the microbiome is balanced, the barrier works efficiently. But over time, stressors begin to damage that integrity, from chronic stress to poor diet, highly processed foods, toxins, environmental exposures, infections, inflammation, repeated antibiotic use, sometimes just one dose of antibiotic use, gluten and glyphosate. All of these things are hugely important in maintaining or in that microbiome losing its diversity. As these pressures accumulate, the tight junctions can loosen and the mucosal layer can thin, and it makes the barrier more permeable. So this is like what what we see, right? So here's what it should look like, and here's what kind of starts to happen. And then right here, you can see all of these things that are supposed to stay within the digestive tract and not come in. Now they can slip through. So the leaky gut describes what happens when the gut barrier loses the integrity and the substances that should stay contained begin to enter the circulation. And this can include bacterial fragments, toxins, and microbial byproducts, which activate the immune system and increase inflammatory signaling throughout the body. And just as a side note, when we don't, because I don't talk about this actually, but when we don't digest our food properly, our proteins, the proteins, which are long chains of amino acids, instead of being broken down into each individual amino acid, it might get broken into segments, which are called peptides. And when those peptides go through and leak into the bloodstream, then that's when we start to get things like molecular mimicry, which leads to autoimmunity, basically. Or those peptides for children, if let's say you're a parent, you've heard of the casein and the gluten and the casein peptide going through and going up into the brain, and it sits on those opioid receptors. And then that's, why gluten and casein can have a negative cognitive effect on children, where it acts like they are on heroin in a way. So these inflammatory signals do not remain localized. They circulate systemically. They can influence the brain immune activity and function, even when digestive symptoms are minimal or absent, which I mentioned earlier. So we're going to go a little bit specific into lipopolysaccharides. So we talked about bad gut bacteria. It can produce metabolites that are unwanted in the body. And those are called endotoxins. So an endotoxin is a toxin that your own body is producing. And lipopolysaccharides is an endotoxin that is very not good for the body. But, LPS might be produced, but if the gut barrier is healthy, it's okay. It can just be excreted. But when the gut barrier becomes leaky, that LPS will enter the bloodstream and it travels to the brain, because once it gets to the brain, has the blood vessels around the brain, there's a barrier called the blood-brain barrier. And if your gut is leaky, your brain is also leaky. That blood-brain barrier is leaky. It mirrors each other. So then the LPS enters your bloodstream through your leaky gut, and then it enters your brain through your leaky blood-brain barrier. And then it tells the mitochondria to stop producing energy and start producing inflammation. So when that gut barrier becomes more permeable, the LPS can pass into circulation. And the LPS, which is that lipopolysaccharide, it's a powerful immune trigger. And when it enters the bloodstream, the body responds as if it's detected a threat. And then it activates the immune pathways, it increases inflammatory signaling. And repeated exposures to small amounts of LPS can keep the immune system in a persistent state of low-grade activation, okay, which is going to be inflammation, right? So these inflammatory signals, they don't stay localized, right? They circulate throughout the body. They influence the immune activity in the brain. So when it gets into the brain, it leads to increased activation of the microglia. The microglia are the brain's immune cells. And so it enters the blood, goes through the blood-brain barrier, enters the brain, and then the microglia get activated. They're sending their alarms. And then there's a sustained inflammatory tone within the brain tissue. And so this is one of the key mechanisms linking gut barrier dysfunction to changes in the brain function, as the brain responds to inflammatory signals originating on the outside. So you got stuff going on in your gut, makes your gut leaky, the bad stuff goes through, goes up to the brain, goes through the brain, sends the alarm bells off on the brain, and now you have inflammation in your brain and your inflammation in your gut. Interestingly, there is a study in Finland that shows that lipopolysaccharides is the #1 marker or predictor for anxiety and depression and other cognitive disorders in people. So the more LPS there is, the more severe the symptoms. So here's something that I don't think you've probably ever heard, but there is a thing called a psychobiotic. So you've heard of probiotics. You might have heard of prebiotics. But probiotics are basically the good microbes for our gut. A psychobiotic so the gut microbiome does more than influence digestion. It directly affects brain signaling, immune activity, and inflammatory regulation. In addition, there are certain beneficial microbes. These microbes are called psychobiotics that produce compounds that influence neurotransmitter pathways, stress response signaling, and nervous system regulation. So these microbes specifically are producing things that are going to be helping things up in the brain. Psychobiotic-supported bacteria help produce short-chain fatty acids that regulate inflammation. They support gut barrier integrity. They influence neurotransmitter production and signaling. They communicate with the brain through the vagus nerve. And rather than acting on the brain directly, they shape the biochemical environment that the brain responds to. When the microbiome is balanced, these regulatory signals help maintain immune stability and control inflammatory tone. And when beneficial species are depleted or outcompeted, so there's more bad than good, the protective signaling decreases and the inflammatory signaling can become more dominant. Brain fog and other brain-related symptoms are often inflammation that started in the gut and not the brain. So most of the time, all your brain stuff really has a gut origin. And in order to regain optimal brain health, we need to address how we are digesting our food so we can benefit from the nutrients. I want to say something about that for a second. Most of the time, all of our gut symptoms are because we are not chewing our food well. We are eating, okay, I was a teacher for 25 years, and what do teachers do? We shove food in our face while we're doing 25 things while the kids are at recess before they come back in, and we have 25 minutes. So if you're eating too fast, you're not smelling your food, you're not anticipating your food, you're not cooking your own food. So then we're not, because all of that helps prepare our digestive system. And then we're not digesting our food well in the stomach. And then by the time it gets into our small intestines, it's not digested. And then it's just a downhill spiral from there. If we don't digest our food fully, we are not benefiting from the nutrients that are inside that food. So you're just eating, if you're eating organic food and you're shoving it in your mouth because you are in a profession that you have very little time to eat and you are multitasking, then that might be very expensive food. You might not be getting your nutrients out of it. All right, the microbial balance in the gut in order to maximize good metabolites and minimize LPS. So we have to address that in part 2 with that microbial balance. Making sure our lawn has, maybe a few weeds, but it's not overgrown. It's mostly grass. It's cut. It looks nice. It's fed. And we need to address the mucosal lining so that the LPS and the other unwanted things can't get in. All right, I wanted to talk a little bit about short chain fatty acids because it's probably new for you, but it is super, super important. Short chain fatty acids are often one of the most important outputs of a healthy gut microbiome. Those metabolites we talked about that good microbes are producing. They are produced when beneficial gut bacteria ferment dietary fibers and resistant starches. So those microbes feed off of fiber and resistant starches. The 3 short-chain fatty acids are butyrate, propionate, and acetate. And their compounds aren't just byproducts, but they're active signaling molecules that influence the gut and the immune system in the brain. They play a critical role in maintaining the integrity and function of the gut lining. So they act as fuel for colon cells. So butyrate is the primary energy source for colonocytes. So those are cells in the colon. They strengthen the gut barrier, so they help reduce intestinal permeability or that leaky gut. They reduce inflammation. They regulate immune responses in the gut. They support mucus. They support the mucosal layer. They help maintain the protective mucus lining. They balance the microbiome, promoting the growth of beneficial bacteria and suppress harmful ones. When the short-chain fatty acid production is low, the gut lining becomes more vulnerable, allowing endotoxins like LPS to enter the circulation more easily. And more often than not, most of us are walking around with a low level of microbes producing short-chain fatty acids. And that's me, I'm going to say, because when I did my last stool test, and even the one I did a few years before, that's what it showed. It's just that the one I did a few years before, I didn't really understand the importance of short-chain fatty acids. But that's a pattern that many people have. And as we age, we have a tendency of having a decreased amount of microbes producing these short-chain fatty acids. Short-chain fatty acids are one of the key ways that the gut communicates with the brain. They influence brain function through several mechanisms. They regulate neuroinflammation. They help calm that microglial activation. They support the blood-brain barrier, improving its integrity and reducing permeability. They influence neurotransmitters, so they impact serotonin, dopamine, and GABA pathways. They modulate the vagus nerve. So the vagus nerve goes up, it's a cranial nerve. It goes from the brain all the way down to the gut. And it affects the signaling between that gut and the brain. And it has epigenetic effects. So butyrate can influence gene expression related to brain health. So I said that things in our environment can turn those genes on or they turn them off. So that's what epigenetics is. And low short-chain fatty acid levels have been associated with brain fog, immune imbalances, cognitive decline, and increased neural inflammation. Short-chain fatty acid production is highly dependent on the environment you create in the gut. So to support it, you need, again, fiber-rich foods such as vegetables, fruits, legumes, resistant starches such as green bananas, cooked and cooled potatoes, rice. So a cooked potato isn't a resistant starch. Once you cool it, and then you can recook it, but once it's cooled, or rice, once the rice is hot, and then you cool it, then it becomes a resistant starch. And then polyphenols, berries, olive oil, and green tea. Diverse microbiome, prebiotics. So prebiotics feed the probiotics. So you have, or the microbes. So a prebiotic feeds the microbes. Inulin is one, fructose oligosaccharides, and the GOS, I forgot what the G stands for, and certain probiotics, especially butyrate producing strains. So these are all the things that can help support short-chain fatty acid production. The things that reduce short-chain fatty acid production is low fiber, like the opposite of what we said, right? Highly processed diets, chronic stress alters the microbiome. And I need to stress that, right? When we're under stress, we are activating the hypothalamus, pituitary, adrenal pathway, that HPA axis, and cortisol production. And when we do that, we are altering and decreasing the good microbes in our microbiome. Who would know, right? Who would have thought? Antibiotics and frequent antimicrobial use. So if you've had a lot of the pattern is, let's say, kids who are on antibiotics and then they go their whole life with very low microbes that produce short-chain fatty acids. When I was a child, I had every year until I was 9, I had an annual ear infection. So I was on antibiotics every year until I was 9. So I know that wiped out my gut. Environmental toxins, so pesticides, heavy metals, additives, all that stuff in our environment. Dysbiosis, overgrowth of harmful bacteria and low presence of bacteria that produce short-chain fatty acids. And then poor bile flow and digestion. So when our digestion is off, when the bile is made in the liver and it's excreted through the gallbladder. Let's say you don't have a gallbladder, you still make bile, but it's just excreted all the time, not just when you eat. The gallbladder, what it does is it holds it until you have a fatty meal or a meal, and then it'll excrete. But if you don't have a gallbladder, it just trickles out all the time. Or sometimes our bile is like stagnant and sticky and not really flowing. Oops. Okay, when your gut isn't producing enough of these key compounds, it's not just a gut issue, right? It affects metabolic health. It affects inflammation, it affects hormone balance, it affects the energy and mitochondrial function, and all of this impact brain performance. And then we get to the issue of toxins. So toxins is like that sand in the gut immune system. And those are chemicals, heavy metals, plastics, mold toxins, pesticides, fragrances, solvents, oxidized oils. Toxins can disrupt the microbiome imbalance and promote dysbiosis. It can irritate and weaken the gut lining. It can increase intestinal permeability, and it can activate the immune responses. And this leads to greater endotoxin or LPS exposure, increased inflammatory signaling, more immune activation affecting the brain, and toxins, they act like constant irritants to the gut barrier and immune system, keeping inflammatory pathways activated. So the body can manage small exposures to toxins, but when the toxin loads exceeds the body's ability to process and eliminate them, then the microbiome balance shifts. The barrier, the leaky gut, right? The integrity weakens, creating leaky gut. Immune activation becomes more persistent, and the inflammatory tone increases. And this creates an internal environment where neuroinflammation is more easily sustained. So our bodies are like this bathtub. We have a faucet and we have a drain. And the faucet is the toxins coming in, and the drain is the toxins going out. When our drains are clogged, or when the faucet is on at a higher force than our drain can drain, then the bathtub fills up with toxins. And once that bathtub fills up, then we get symptoms. And when that bathtub starts to overflow, then we get more serious symptoms, and autoimmunity results with that overflow bathtub. And with our children on the spectrum, our children with autism or even ADHD or whatever, our kids, they're born, babies today in their umbilical cord, babies today are born with over 300 chemicals in their umbilical cord blood that aren't supposed to be there and that weren't there, maybe let's say 50 years ago or something. So the babies are born with a very full bathtub. And that's why it just takes a vaccine or takes whatever just to overflow that bathtub. But the people who are, like my mother, she's 75, or, people 75, 85, 95 years old, maybe they're just, their bathtubs are just now overflowing. So maybe they're getting the Alzheimer's because their brains were already developed. They're not getting autism at 85 because their brain's already developed when it's supposed to develop. The babies, these toxins and these things are blocking the normal development of the brain, which is why they have all these child symptoms. And then these exact same toxins are causing just different symptoms in the elderly, but it's really the same mechanisms and the same toxins. Okay, everyone tries to mop the floor instead of opening the drain. And that's what the symptom relief care is. Okay, so mopping the floor instead of A, unclogging the drain, and B, turning off the faucet.